Hi, thank you for tuning in. Also, big thank you to AWS and all the community heroes for organizing this event. I'm very excited to be here, and today I'll be talking about how we are curating data to power deep learning at Nearmap. I'm Suneeta Mall. I work as a principal machine learning engineer at Nearmap. There, I lead a team called Data Engine who are responsible for model data, model training, model deployment, and continual improvement over this. I have a PhD from University of Sydney and have a 13 plus years of IT industry experience working on various domains such as machine learning, data science, big data, travel, GIS, DevOps, and many more. I love mentoring and learning things. I also speak at technical conferences, particularly on topics such as machine learning, data science, or Kubernetes or distributed computing. I author for O'Reilly and I have also authored for IBM Redbook in past. Nearmap is the provider of high definition aerial imagery content. We have petabytes of aerial imagery already, and we are every day capturing terabytes of more and more content. With Nearmap AI, we are taking these visual contents and generating semantic knowledge on top of it. We are essentially building knowledge layers for various things and stuff in our livable world. Things like driveway, power pole, power lines, various types of vegetation, swimming pool, roof, solar panel. In fact, we already have 30 plus attributes already ready in production for customers' use, and we are rapidly growing that list as well. We take these semantic knowledge web and then we convert them into what we call location intelligence. And one such example of location intelligence is shown on the screen here. Here we are talking about the details of building, like what is the building footprint, what kind of material was used in this roof, like if it's tile, shingle, and what is the style of roof, hip, gable, etc. And likewise, if there are any tree overhangs, and if it is, then what is the size of overhang. We do this to simplify our end users and customers' product and workflows. So, what underpins this sophisticated Nearmap AI product is a technology called deep learning, and I'm sure many of you would already be familiar with this concept. It's essentially a class of a supervised machine learning technique or a deep learning technique where we give a mathematical model a source image and also a ground truth. And when the model looks through the data, it learns the feature representation or a knowledge representation by looking at data. And once it has learned, then we are able to give any image to it, and it is able to predict with certain confidence to what attributes or things a pixel may be, things like swimming pool, roof, etc. Deep learning techniques are hungry for two things: data and also accelerated computing. But today, given we are talking about data track and the focus being data, we will just talk about data and leave the acceleration piece out of it. So at Nearmap, we have various type of visual contents. We have ortho images, oblique images, and also various forms of 3D images like mesh and point cloud. These images help us visualize a certain location from many different views and allows us to really visualize a location or an object to a certain what it is, because sometimes when we are looking at from a different view, it's really hard to tell what we are looking at. And we leverage on these vast visual library that we have to generate a really good quality of a ground truth. So to leverage on that, we have an inbuilt or in-house built labeling system that our labelers use, wherein they can leverage on these various type of imaging modality and really visualize a location before they annotate it for various attributes or things and stuff. And I would like to also mention that we use well-trained staff, so they really understand the definitions of the attributes that we have in our system. So this is an empirical study that did analyze the impact of data on deep learning. And they found that as we increase the data or the training data set, the model starts to perform better and better. And it actually, the validation loss reduces sublinearly. What that tells us really is, as the bigger the training data is, the better the model would be. So sure, data size is important, but data size isn't the only solution, as the same study indicated that once you get out of this power law region where you can keep growing your data set and continually keep reducing your validation errors or generalization errors, then you come to converge into this irreducible error space that is really hard to um, close further in. So data matters and size matter, but what's more important is data quality. And it's quite intuitive if you look at it. The model is learning the knowledge representation by looking at the data itself. And if the ground truth is not correct, then we can expect the model to perform poorly. And this is very well represented by this little cartoon here. And when we talk about quality, we are not just talking about correctness, but we are also talking about variety, as it's shown by this little meme here. The only thing that's true in our world is imperfection. We as humans are imperfect, and also all models are wrong, only some are useful. And this is very interesting situation because we want our training data to be perfect data set, but all sources of generating it is quite imperfect. And I will give you examples to confirm that, I guess. Let's talk a little bit about the workflow that we observe on the data engine side at Nearmap. And what we are looking here is a very standard AI machine learning data workflow where we have a label capture program, then a ETL pipeline, then a model training program, and then model deployment. But at Nearmap, we have come to evolve this workflow quite extensively, and I'll take you through that. One adaptation is adding the review or correction workflow where jobs are reviewed by another labeler to make sure the quality is correct or acceptable. And then as our models are out in the wild, they are doing inferences, we do a monitoring where we look at the locations where our models are uncertain about, and we pull that back into our data set. And then we perform what we call adaptive sampling, and this is a mechanism to pull in locations and images where our models are not confident and feed that back to labeler to generate ground truth, and then back to model training to get our models to continually perform better and better on the things where it hasn't been very confident in past. And then we also utilize our model into labeling system where we pre-populate the labelers uh, job with the model's prediction, and then we allow labelers to correct it instead of painting on an empty canvas. We do this with the hope that this will help them have a better labeling experience and also do an efficient labeling. In fact, we also did a survey with our labelers, and the results indicated that our labeler thought that pre-population helped them perform labeling much more efficiently and accurately with pre-population. And then we also utilize model in quality check programs to identify where the ground truth data may be incorrect. And I will lead you with various examples to help you understand why we have adopted these approaches. So first is mistakes are real, mistakes happen. They happen just because we are human. This is one such example where labeler was to annotate roof, and he missed that particular highlighted roof but labeled everything else correctly. And then sometimes we make mistake because objects are really hard to perceive, or there is cognitive issues in identifying objects where in this example where you can see that particular car is really hard to spot, and this labeler missed annotating it. And then we also see some really strange cases in the real world that is really hard to explain. Like in this example where a trampoline is actually kept in a empty swimming pool in a family's backyard. And if you don't see these visual examples, it's really hard to imagine these scenarios being real, but there we have it in real time. Another approach that we adopt is majority, where we give the same job to many labelers and take the majority opinion as the final ground truth. And in this example, the labeler drive annotating for driveway actually annotated the entire drivable surface, including the parking spot, which is not quite correct. But when we took majority, we actually had the right definition of driveway there. This is obviously quite expensive operation because the same job is being done by many labelers at the same time. Okay, so let's talk about how we are using model in quality check. Here, there's a job that was given to a labeler to annotate natural soft, meaning dirt, and grass. And this is the label returned by the labeler. And as you can see, the labeler completely missed annotating grass and actually only annotated dirt. But even for dirt, the annotations are not quite correct. There are patches of dirt that's not correctly labeled. You can see little bits of dirt shown not annotated. Now we do understand it is quite hard class to annotate. It's quite ill-defined and wiggly, but not having the correct representation or correct ground truth is not going to help us with a good model. So it's really important that we identify these issues. And another example that was picked by using model in the loop for quality check is this, where a particular labeler missed annotating water in the entire image completely. This is another interesting case where we use model in the loop for quality check. And here we are looking to identify errors in the label due to noises in the image. Noise could be related to the capture condition, like maybe there is a cloud, maybe the image is grainy, or possibly the lighting conditions are not quite correct, or maybe there is occlusion, shadow, or many such reasons. And to identify issues coming from this, what we do is we look at predictions over many images captured at a different point in time and find an average prediction for for the objects we are interested in, and we compare it against the labeler's truth. And here, as you are seeing, we are identifying this particular job being poor because the labeler has missed annotating the middle swimming pool. And then the example of using model in the loop for annotation. So this is a good example of both human and model in the loop. The job is being pre-populated with models' opinion of what the label should be, and then we use labelers to correct model's prediction. And the purpose here is two-phased. We are not just looking at helping labelers do efficient labeling, but also identifying where the difference is in the opinion between the model and also the labelers. And this data could be very useful for us to understand where our models are doing poorly. And then all these various ways of quality check and data quality and data management is important. But what's also important is continually updating the definition of attributes that are already strong. And this is important because our definitions of things and stuff continually change uh, as we go in progress in time. And this is good example here where the definition of car as envisioned in the 80s has drastically changed to how we envision car currently. And if we don't continually keep updating our data set, then we run the risk of concept drift or data drift, where our data or the model's understanding of what the feature is drifts away from the reality. And for this reason, we also continually keep updating our data set with the strong classes as well. That was all about data. Now there's a lot goes on the data engine side. There's a lot on machine learning side, then model management, model monitoring, and also what happens with attributes and their relationship between them. This brings us to Techstack. This is our bird eye view of technology stack, and as you can see, at the heart is AWS, which is our choice of cloud provider. We quite heavily use EC2 and S3 along with other AWS services as well. In fact, we are one of the biggest users of S3 in Asia Pacific. We We prefer Kubernetes as our choice of container orchestration platform, and most of our workload are containerized. On the data side, we look at Snowflakes and Looker for analytics and reporting things. We use Kafka as a messaging and um, backbone, and we use TensorFlow as our deep learning SDK, and then Python, Golang, and C++ as our language stack. We have actively talked about how we utilize AWS and AWS services in our workflow and how we run our applications at scale, both in terms of compute and also data. And while we do that, how we keep our cost minimal by making use of spot instances and various other tweaks. And I would like to point your attention to these links that talk a little bit more in detail around those things. And with that, I would like to take a minute of yours to talk about Rehiring. We are looking for software and data enthusiasts to come and join our team and help uh, take Nearmap AI to the next level. So, if what we talked about today and what we are doing with AI, deep learning, or engineering, if this seem of interest to you and you would like to find out more, please feel free to reach out to me. My details are mentioned there. I'm also available on LinkedIn and other social networking channels. And also, if this is not the right time for you, if you are not looking for opportunities and you would just like to reach out, have a chat, or maybe exchange notes, please feel free to reach out. I'll be very happy to have a chat. And with that, I would like to take questions if there are any. Thank you.